Now, question 8.1, we are asked to find the derivative using first principle of this function here of f of x equals to minus 3 over x. So to find the derivative, our f of x is equals to minus 3 over x, and our f of x plus h is going to be equals to minus 3 over x plus h, right? So the derivative is equals to the limit when h approaches 0 of f of x plus h minus f of x divided by h. So it's going to be limit when h approaches 0. So we'll write f of x plus h. We're just going to write this expression here. So it's going to be minus 3 over x plus h minus, we're going to put this expression here. So it's going to be minus 3 over x divided by h. So let's first simplify this expression here. So it's going to be minus 3 over x plus h minus, the minus will multiply the minus, so it's going to be plus 3 over x, right? So we're going to find the common denominator, which is x plus h and x, and then this x plus h will cancel out this x, so it's going to be minus 3x plus, and this x cancel out with this one, so it's going to be 3 into x plus h. So if we simplify further, it's going to be minus 3x plus 3x plus 3h over x into x plus h. So this minus 3x and this 3x going to cancel out, so you're going to have 3h over x into x plus h, right? So we're going to write it here, limit when h approaches 0, so it's going to be 3h over x into x plus h, right? Divide by h. So which is going to be the limits when h approaches 0. So it's going to be 3h of x into x plus h multiplied by 1 over h. So this h cancel out with that h. We remain with the limits when h approaches 0 of 3 into x plus h. So we're going to substitute this 0 here. So it's going to be 3 into x in x plus 0, and then we'll remain with 3 over x squared. So this is going to be our derivative. 8.2, we're going to find the derivative of 8.2.1. So the derivative of this problem here of 3x cubed minus 2 to the power of 2. So we're first going to expand, so it's d of x into 3x cubed minus 2, 3x cubed minus 2, and we're going to find the product. So it's going to be this multiplied by that. It's going to be 9x to the power of 6 and minus 6x to the power of cubed minus 6x to the power of cubed plus 4. So the derivative of 9x to the power of 6 minus 12x to the power of 3 plus 4. Adding these products here gives you this. Then now you can find the derivative of this problem here. So meaning that you drop the 6, so it's going to be 6 into 9x to the power of 6 minus 1 minus 12 into 3 x to the power of 3 minus 1, and the derivative of 4 is 0. So 6 multiplied by 9 is going to give you 54, so it's going to be x to the power of 5 minus 36 x to the power of 2. So this is going to be your derivative. 8.2.2, we need to find the derivative of this expression here. So we have y is equals to 2x cubed minus 4 over x plus 4 cube root of x, right? So the first thing is we need to write down our expressions properly. This expression, we need to write it properly, and this expression, we need to write it properly, right? So first thing we're going to do is we're going to say y is equal to 2x cubed minus 4 x to the power minus 1. So you're going to take this x to the top, and plus 4 multiplied by x to the power of 1 over 3. So how did I find that? When you have the cube root of x is to the power of 1, and this is 3. So this 3 is going to go at the bottom here, right? So meaning that's going to be x to the power of 1 over 3. So y is equals to 2x cubed minus 4x minus 1 plus 4x to the power of 1 over 3. So now we can derive. So we're going to drop this 3 into 2x to the power of 3 minus 1. Then we drop this minus 1, so it's going to be positive 4x to the power of minus 1, and then we drop the 1 over 3 multiplied by 4x to the power of 1 over 3 minus 1. So the derivative is equals to 6x to the power of 2 plus 4x, so it's 4x to the power of minus 2 plus so it's plus 4 over 3x to the power of minus 2 over 3, right? So you can leave your problem like this, or you can simply write y derivative is equal to 6x squared plus so you're gonna drop this x to the power of minus 2. You have 4 over x squared plus 4 over, so you drop this also because the power is negative, so you're gonna have 3x to the power of 2 over 3. So this is your derivative. 8.3. So we are asked to determine the coordinates of the point of the curve of y is equal to 2 into 1 minus x all to the power 2, where the tangent at this point is perpendicular to this equation here. So if the tangent is perpendicular to this equation, which means now the m of t multiplied by the m of this equation, which is minus 2, gives you negative 1. So we're going to divide by this, so it's going to be m of t multiplied by negative 2 equals negative 1. Then we divide by negative 2, divide by negative 2. So the gradient of the tangent is 1 over 2, right? So when you have lines that are perpendicular, the gradient, the product of those gradient must give you negative 1, which is this point that I did here. So hence our gradient of the tangent, we know it's 1 over 2. So let's solve this problem here. So we now know that our gradient of the tangent is 1 over 2, right? And our equation, which is y is equals to 2 into 1 minus x to the power of 2. So let's first derive this, but before we derive, let's first find the product of this. So it's going to be y is equals to 2 into 1 minus x, 1 minus x, and the product is 2 into 1. This 1 multiplied by 1 is 1. This 1 multiplied is x minus x, and minus x plus x squared, which is 2 into 1 minus 2x plus x squared. So we multiply the 2 inside. You're going to get 2 minus 4x plus 2x squared. So if you write it properly, you have 2x squared minus 4x plus 2. So this is your equation of y. So for you to find, normally when you find the gradient of a tangent, you need to derive your equation of 2x squared minus 4x plus 2. So the first derivative of your function is actually going to give you the gradient of your tangent, but we're looking for the coordinates here. So we first derive, we're going to have 4x minus 4, right? And we found the gradient of the tangent being 1 over 2. So we're going to substitute it at y prime. So it's going to be 1 over 2 is equals to 4x minus 4. Transpose the 4 to the other side. We have 4x equals to 4 plus 1 over 2, and then we divide by 4, so our x value is equals to 9 over 8. So this is the x value. Then you're going to substitute this x value into your equation to find the y value. So you're going to substitute it to the original equation of y is equals to 2 into 1 minus x to the power of 2. So to find the y values, y is equal to 2 into 1 minus, you have 9 over 8 all to the power of 2, you're going to get a value of 1 over 32. So these are your coordinates, which is 9 over 8, and 1 over 32.